So let's quickly do this little calculation then. So I first of all need to work out, first of all I'm just going to draw a little table. So bonds broken, or in other words the bonds between the reactants, and on the other side bonds formed. In other words, bonds between the products. Okay, so it's simply a case of adding up the total amount of energy in the bonds, first of all, of the reactants. Okay, so how many we've got this bond here. Okay, so we need to break that bond. There's only one of them, so we need to break 1 times hydrogen bond. And if I look over the information I'm given in my table here, no, that's the wrong one, sorry, it's this one. Here we go. So that's 1 times 436 equals 1 times 436 kilojoules per mole, which is obviously 436. Quiet. And, sorry, the other bond I need to break, of course, is this bond here. So there's just one of those, so 1 Cl bond. And again, I just need to look at my table here, and that's just 1 times 243 kilojoules per mole. And that's obviously 243. So in order to calculate the total amount of energy which is being absorbed, the activation energy in order to break those bonds, it's simply 436 plus 243, which is 679. So the total is 679 kilojoules per mole. So that's the energy in order to break the bonds. And then, of course, I'm doing the same for the energy released when new bonds are formed. So this is a bit more, perhaps a little quicker. So how many bonds are formed? Well, 2 bonds are formed. They're both the same type. So 2 times hydrogen-chlorine bonds. And so the energy there is 2 times HCl. 2 of those, so 2 times 432, which is obviously 864 kilojoules per mole. And remember, the overall energy change can be calculated is equal to the energy of the reactants, 679, minus the energy of the products, 864, which is, if I just get my calculator out, 679 minus 864 comes out as minus 185 kilojoules per mole. And because it's a minus number, you know this is an exothermic reaction.